What do you do? I do 3D stuff. Yes, assorted 3D stuff. So I was asked to give the inaugural guitar talk on 3D printing. So I decided to essentially give everyone a crash course on what it is, steps involved, and also the technology. And from Alright, so I thought we'd start with an introduction to 3D printing in case anyone doesn't know what it is.
What's a bit older?
Talk a bit louder.
Sure. Alright, so I wanted to give a quick introduction to what 3D printing is and why it's actually interesting, why it's relevant.
Whoa, that's fancy!
So essentially 3D printing is the process of additively building a 3D model, typically out of cross sections. So we'll start off with a 3D digital design, something like the skull, and we'll build it up layer by layer. So here you see a skull which essentially isn't complete. So it allows us to take 3D digital models, make physical copies, which is really useful for a lot of industries. Subtractive versus additive. 3D printing is additive printing. All of these were printed using a computer-controlled machine from a 3D digital model, but they are not 3D printed. These were all started off with a large mass of product, and the product was sent to blank, and that's how you end up with these designs. So it's more like sculpture.
Are those wood?
They're wood, yeah. All of those. So CNC printers look very similar. They have some kind of cutting device to essentially remove material out of the block. It's just the opposite in non-classified. So what's it good for? Well, industrial design was one of the first industries to adopt the technology. It's very common for architecture and also automotive design. Obviously, car panels, they have lots of funny curves and stuff, so they're difficult to manufacture using standard techniques. So coming up with prototypes like this car, which is entirely 3D printed, is relatively straightforward with this technology. Elsewhere we have fashion. There's two very uncomfortable shoes. There's a bikini top, which is entirely 3D printed, no fabric, plastic. And also jewellery. This is actually a solid gold printed, which is pretty cool. Next, obviously, we have medicine. So here was a lower jaw printed out of titanium. There's an 83-year-old patient who lost her jaw due to infection. Typically with younger patients you would use some kind of graft to take bone and that sort of thing, but because of her age they decided to replace it with an entirely prosthetic jaw. For anyone who hasn't seen it, there's also Emma and her magic arms. This is a young girl who essentially doesn't have the muscle strength in her arms to lift her arms. So they've designed an exoskeleton out of 3D printed parts, which is really great because as she grows they can really quickly make new parts to fit her, and it also means as they break they can produce replacements very quickly.
What are the advantages of using 3D printer versus like a standard, whatever they use, tools they use before?
Essentially time. So if you're wanting short run, rapid prototyping, a 3D printer can turn it out in an afternoon. Yeah, essentially as needed. So it's not a large scale fabrication technique. If you wanted something where you want 10,000 pieces, 3D printing is not the way to do it. You can do something like injection molding. But if you want one injected molding piece, you have to pay thousands for the mold. It takes weeks. So it's not a good way to test things out.
An example of replicating parts. The other day our 3D printer broke down. So Jeremy used the 3D printer to print a part for the.
So there's actually a clip back here which broke, and I replaced with a printed part. So I essentially jammed it in with hot glue just so I could then print that part, replace it with the actual thing. So next we have art, obviously. 3D sculptures, characters from 3D digital models, all very cool. Food. Food is the interesting one. So these decorative icing areas were actually 3D printed in China. This is available at the Google headquarters cafeteria. It's pasta that was printed. So they can print pasta in a whole variety of shapes. Something like this is cool because you can put sauce and that sort of thing. But it's very interesting. And there's also kiddie cosplay and other useless stuff. So that's essentially a very quick overview of what 3D printing is, what it's used for currently. So next I wanted to give a quick overview of where the technology came from and also where it might be headed. So as with everything great, it started in the 80s. In 1986, stereolithography was invented. So it was developed by Charles Hull in 1984. It was patented in 1986. He then went on to form 3D systems, which is actually still around today, so we're using printers. Based on a lot of the feedback from their early test printers, which they only released to very select clients, they came up with the SLA 2502, which was released in 1988. Complete with 80s computer. CD-ROM, of course. So essentially stereolithography is a process which uses optical light, UV laser, selectively bonds a UV reactive material. So the material is laid out in the liquid, the lasers then pass over the liquid and selectively bonds essentially anywhere it is. So it's a fairly expensive process. There's obviously a lot of moving parts, the material is expensive, so there's drawbacks to it, but it was still pretty good. So here we see a completed model, so this is the areas that have been hit with the laser coming out of the liquid. And it's also a special lighting because obviously you don't want a UV to the edge, otherwise you don't need anything out. So these are automotive parts, car panels. So then in 1987, we ended up with selective laser sintering, which was done by Carl Deckard, this very small-looking chap. And they produced the first selective laser sintering machine in 1992. So laser sintering uses some kind of powder, and it essentially selectively melts the powder layer by layer using a laser. So in this case, it's a carbon dioxide layer. So it just creates layers and layers of ink, which then fills up in time. So because it's in a powder, it's really good because you don't need support structures. Essentially, the release layer of powder, bonded or not, serves as support for that bond. So then you essentially just remove the bits that have been bonded out of the powder that hasn't. So you're just shaking all the bits out. Then they use something like compressed air to then remove any excess powder from the mold. And in the end, he ends up in a very sporty looking handbag. Just in case, for the woman. Then by 1988, we end up with fused deposition modelling, developed by Scott Crump, who formed Stratasys, which is also available today. So Anna's Magic Arms were printed on Stratasys. The first FDM printer went on the market in 1992. That's where it is, complete with a blue neon gradient. So FDM uses essentially a hot glue gun to print out layer after layer of material, generally plastics, essentially anything you can bring to a molded state that will then harden when it prints. So this is printing some kind of funny object. So you print the support structure initially because there is no layer of powder or fluid underneath to hold it up. And then that's removed from the support structure. I'm not actually sure what he's printed, but there you go. So FDM is exactly what the Ultimaker is. It's a much more cost-effective way of developing a printer. There's a lot less moving parts. You're not having to use expensive materials. There's a lot of benefits to it. So then we come over to 1993, where we end up with three-dimensional printing. This isn't 3D printing, it's officially three-dimensional printing. So it was developed by MIT, licensed to Z Corp, which is now part of 3D Systems. And they developed the Z4 which was released in 1996. So essentially it uses, in this case, common HP ingot cartridges. It prints on a layer of powder, essentially plaster, a little bit of vinyl, and bonds the material selectively. So it's a little like selective laser sintering, but it doesn't use heat to bond the material, it uses ink. And then the powder moves and you end up with the product. The really cool thing of this is you can print in full colour. So they can do some pretty cool stuff. So then in 1996, we ended up with the term 3D printing. In 2006, the RepRap project was announced. So for those who don't know the RepRap, it's the first open source 3D printer. It was something designed that you could build yourself, order a kit, that sort of thing. So before then, it was essentially only industrial use, large companies. So this was a big deal. So then in 2008, the RepRap became available. It was capable of printing 50% of its own parts, all these white parts here were printed with the RepRap. It was also the first popular 3D printer. So then in 2011, the Ultimaker came along. It holds a few records still. It's the fastest. It definitely has a simpler assembly than the RepRap, which was notoriously difficult to put together. Has a pretty large material volume and it's quite high resolution. Along comes 2012, we end up with an awful lot more. So this is essentially the great grandchild of the RepRap. That's the Airwolf. There's the Megabot, CNC. This is the Solid Doodle, which comes fully assembled for about 500 US. The Fab at Home, this uses syringes rather than any kind of specific heating element. So you can essentially print whatever you like. You can get it in a syringe, you can print it. Icings or cookies, that sort of thing. And this is the Cubify, which is kind of designed to be idiot-proof. Essentially, it's the Apple of the home 3D printers. It comes ready to print, requires almost no maintenance. Not the greatest printer, but good if you're not certain, not technical. So, as for the future of 3D printing, we end up with something called bioprinting. This is human skin. So essentially printed layer by layer using skin cells. The idea is you'll be able to print skin for burn victims or a wide variety of other conditions and graft it onto the patient. The ultimate aim is to be able to print directly on the patient. That's obviously the goal. After that, we move on to other areas of bioprinting, which is the attempt to print organs, other organs, kidneys, hearts, that sort of thing. It's actually relatively straightforward to print living tissue. Printing kidney cells isn't that difficult. What's difficult is keeping the kidney alive while you're printing it. One of the real issues is blood supply. You're not supplying cells with oxygenated blood, so they die very quickly. So here's some guys who are using a modified RepRap. They're printing sugar matrices so that they can essentially develop blood vessels during the printing process. So this way you can pump blood into the cells while it's printing and keep all the cells alive during the fabrication system phase. So here he is printing the sugar. They then inject a gel solution which essentially forms around the sugar. They dissolve the sugar and you're left with blood vessels. So after that, we move on to food, which is a related topic. Obviously, I showed you some earlier examples of printing for food. There's a company called Ultimaker. They recently got quite a bit of funding from the PayPal founder. They're wanting to print meat from scratch. Producing steak has a pretty catastrophic environmental impact. Livestock are really, really bad for the environment, and as the population grows, either we all turn vegetarian or we start eating printed meat. So that's the idea.